Okay, we're at gotomath.com. Let's click on the calculus button and go down to finding the area between the curves, around the curves or something like that. Find the area of the shaded region around answer 3. Alright, let's go. Whoa, my God, what is that? Find the area of the shaded region around answer to 3 decimal places. So we got some exponential functions. That's Euler's number in there hiding out. Some speculate that E stands for Euler. Leonard Euler, ever heard of him? Probably not. Maybe you have. Anyway, we want to find this area here. And it looks pretty easy. We're going from 0 to whatever in the world this x number is here. Yes. So let's write this one down. Now I'm going to tell you 6.2. That's going to be your homework assignment. That's a challenging problem. I'm just warning you right now. Really, the only challenge is you're going to have to use Newton's method to find the 0 to the polynomial. Actually, it's not a polynomial, it's an exponential function. Actually, it's pretty nasty, whatever it is. I'm just warning you. Anyway, we will do a trick here, though. So, want to find this shaded region. We got everything written down. Let's head over to the whiteboard. Let's, actually, what I need to do first is write these guys down. So, f of x is equal to e to the negative x plus 4, and I guess we'll just write g of x underneath it, is equal to e to the x. Right? So let's say here's e to the x going up like that, and this guy right here is going down. It's going to cross here though. Let's see, 0, 5, going to cross at 5, but it's actually going downward like that. Right, and we want to find this region right here. So we know we're going to be going from 0 to something, but what is that something? That's the question. This guy right here, what is that? Well, we have to set both these equal to each other. You'll like this. This actually took me a minute or two to figure this one out. You know, let me see something here. Okay. I guess I just need to work it out. Okay, so what do we do here? Well, I'm going to actually rewrite this. Let's rewrite this as 1 over e to the x plus 4 equals e to the x. Alright, let's multiply e to the x all the way across. So that becomes 1 plus 4e to the x is equal to e to the x times e to the x. Okay, and we can actually rewrite this. 1 plus 4e to the x is equal to e to the 2x. Probably like, what in the world am I going to do with that? Well, I'm going to show you. Alright, let's take everything over here, let's take it over to the right. So we have 0 is equal to e to the 2x minus 4e to the x minus 1. Now we're going to do we're going to do some substitution here. We're going to let u equal e to the x. Let u equal e to the x. Now this guy right here can be rewritten as, we're going to actually rewrite this, e to the x quantity squared minus 4e to the x, like that. Okay, now we're going to substitute this e to the x for u, because u wants to be go in there. It's now his time to show his self. Alright, so now what we've got is something that we can take the integral of. I mean, not the integral of. Some we can actually, in a form we can actually take or solve for you in this problem. And once again, what I'm going to do here is I'm going to complete the square, give you lots of practice completing the square, right? So we're going to rewrite the u minus, take a half of that, which is 2, square it, always write a minus sign here and then square this number, and that's going to be a 4, and then rewrite minus 1. Alright, okay. So you can't forget your algebra now. We're just rewriting, cleaning it up. Now what I'm going to do is go ahead, take this 5 over. We shall square root it. Remember, it's a plus or minus, and then take the 2 over. And there is our u. Holy smokes. You gotta be kidding me, right? Alright, let's look at something here real quick. Remember, this is the positive value, but that doesn't really matter. I mean, it does and it doesn't, because we're going to be using the plus sign here and not the minus sign. We're going to be using the plus sign. Alright, so since u is now equal to the square root of 5 plus 2, remember what u was equal to. It was equal to e raised to the x. E raised to the x. Alright, and so that means that e to the x is equal to the square root of 5 plus 2. Square root of 5 plus 2. How do we solve for x? We take the natural log of both sides. So ln e to the x is equal to ln of square root of 5 plus 2. Alright. And of course, this, you can take, this is the power rule part of not taking derivatives, but it's one of the laws of natural logs. You take that x, bring it out front. Natural log of e is 1, so we're left with x is equal to the natural log square root of 5 plus 2. So finally we got x, the natural log of the square root of 5 plus 2. Remember that. The natural log of the square root of 5 plus 2, right? Okay. So finally we found our upper limit. So remember, you take the top curve minus the bottom curve. Okay, so the top curve happens to be this guy here, which is going to be e to the negative x plus 4 minus the bottom curve, which is e to the x. Right, dx. Okay, so we want to go ahead now and take the integral of this. Now I'm going to tell you this part right here. When we take the integral of e raised to the negative x, okay, we normally do u substitution where we let u equal negative x, and then, you know, we go through all that, but I'm going to kind of skip that. Okay, so hopefully you know how to take the integral of e to the negative x. Okay, well, I'll just tell you, e to the negative x is negative e to the negative x. That's what it turns out to be. Remember, use substitution, let u be this. I'll let you work on that. Plus 4x minus the integral of e to the x is just e to the x. Okay, and we're going from 0 to the natural log of the absolute value of 5 plus 2. Absolute value 5 plus 2. So now what we'll do is we'll plug everything in. So we got negative e to the negative natural log of the square root of 5 plus 2. Okay, plus 4 times the natural log of the square root of 5 plus 2. Close that parentheses up. Minus e to the natural log square root of 5 plus 2. Now this stuff simplifies down, believe it or not. E raised to the natural log is going to collapse down, and it's just going to be this, square root of 5 plus 2. So this can all just be replaced with square root of 5 plus 2. Same thing going on here, except we have a negative up here. Alright, anyway. And then minus, start a big parentheses here, and then we plug 0 in, so 0. E to the 0 is a number raised to the 0 is 1, so that just becomes minus 1. Plus 4 times 0 is just 0, minus e raised to the 0 is just 1 again, right? So look at here, we got 1 minus 1 is negative 2, but then we got a minus out here, so that makes that a positive 2. All right. Okay, getting you warmed up for the next problem. All right. So I ended up getting, that's right, approximately 3.302.405 or something like that. Yeah. And so what do we got going on now? We got, we're rounding to 3 decimal places, I believe. 3.302. Rounding 3 decimal places, I can't remember. Yes, that's it. I already did that. 3.302. And I checked this, tried checking this in Mathematica. Mathematica said it could not solve, it could not solve it. So, well, I know teachers always like to find problems that algebraic systems can't work out. Anyway, don't know if the TI-89 can actually do it. That was actually where I tried that out at. Said it couldn't do it. Anyway, there we go. Wolfram Alpha. Alright, I always check this with algebraic systems and making sure everything's good. Anyway, so what are we doing? 6.1? Alright, let's go back to the house. Back to the house, check it out. Be there, be square, bye.